In 1928, Professor Alexander Fleming discovered penicillin by accident. Fleming was studying the natural antiseptic he discovered in the human teardrop that destroys bacteria at an alarming rate. While doing his study, he found a peculiar mold in one of his cultures of Staphylococci, or staph. He observed that this mold was dissolving his Staphylococci. He named this mold Penicillium chrysogenum, or simply penicillin. In 1929, Fleming presented his penicillin case study to the Medical Research Club in London, England. His case study showed that not only does it destroy staph, but it also kills off gonorrhea, meningitis, diphtheria, and pneumonia, all of which are bacterial infections. The death rate of bacterial infections during this time was very high. About 90% of people who contracted HIV, AIDS, malaria, gonorrhea, measles, pneumonia, and tuberculosis died of it. The 20th century provided us with a variety of wonder drugs that for the time being fought off many superbugs.
And then in the 90s and currently we're using combinations where they put multiple antibiotics together in combination drugs. And that's mainly because we haven't seen really a new antibiotic on the market in probably 10 to 12 years.
The thing that is new is that while bacteria continue to develop resistance, we've stopped developing new generations of drugs to keep up with them. That's what's changed in the equation.
In 1939, war had broke out across Europe. The ratio of infectious deaths to combat deaths was 1.1 to 1. Penicillin was tested only on animals in 1940, but by 1941 the first human test subject was on a World War II soldier. The success of penicillin brought world recognition to Fleming. Fleming, Chain, and Florey all received Nobel Prizes for their work. By the end of World War II, the ratio of infectious deaths to combat deaths was reduced to the ratio of 0.06 to 1 with the aid of penicillin.
Through mass production methods, America is continually increasing its output of penicillin, a new drug that effects almost miraculous cures. The liquid medium in these bottles will grow the mold that forms penicillin. First, however, the liquid is purified by sterilization in great ovens. After sterilization, the medium is carefully inoculated with the seeds of the penicillin mold. The next step is incubation. Slowly, the mold that contains the precious drug forms in the bottles. All penicillin produced is used by the Allied fighting forces. The liquid, now charged with penicillin, is poured from the bottles. Turned into a powder, it is ready for use.
In 1947, physicians observed the first case of clinical resistance. The war of bugs versus drugs had begun.
So antibiotic resistance happens when bacteria kind of change their physical characteristics from generation to generation. They combine different characteristics from generations before, and they can create a new generation that is more resilient and resistant to drugs. So the pathogen might be able to completely inactivate the drug, or they might be able to alter themselves so they're not susceptible anymore.
In 2002, France launched a campaign with the aim of decreasing antibiotic prescription use. At this time, France was consuming more antibiotics than any other country in Europe, and they were facing an antimicrobial resistance problem. The threat of a widespread antimicrobial resistance raises spectra of a world without effective antibiotics. A world where a patient can die from an infection that we once said was easy to treat. Over 190 million doses of antibiotics are prescribed each day. About 50% of those prescriptions are not finished because the patients start to feel better and stop taking their antibiotics. But how does that affect you?
If you don't take your full dose, you're putting yourself at risk basically for a reinfection. So basically you take the antibiotic, and what we always tell patients when we give them an antibiotic is you might feel better in 1 to 2, maybe 3 days, and you should, but you still need to finish the course because the bacteria is still in your body. And so if you just stop after feeling better, that bacteria has another chance to multiply. But if you keep
Antibiotics are very powerful drugs, but they are not the cure for everything. They are meant to fight infections caused by bacteria and are ineffective against viral infections, like the common cold, most sore throats, and the flu. By taking an antibiotic you don't need, or by not finishing your entire dosage, you are putting not only yourself at risk for resistance, but also your community. Antibiotic resistance has been called one of the world's most pressing public health problems. The smart use of antibiotics is the key to controlling the spread of resistance.
It's a challenge. The future will be a real challenge for antibiotic therapy because the bacteria are getting smarter. They're becoming more and more resistant. We've overused antibiotics for too many years, for too many minor things that we're not treating anymore with antibiotics. But unfortunately, we've created our own superbugs. So.